Hello students, my name is Dr.Archana Khandelwal from Biyani Girls College, Jaipur. I am assistant professor having 20 years of experience. Today's my topic is truth table, which is topic of discrete mathematics. Now let's start the topic. What is truth table? Basically truth table is used for decision making process. Proposition calculus, it is a topic of proportional calculus where some propositions we use to determine their truth or false values. Like truth table is used to perform logical operations in maths. These operations comprise Boolean algebra or Boolean function, means by using logical propositions we form their functions and conclude their result whether they are true or false. It is basically used to check whether the proportional expansion is true or false as per the input, right. This is based on Boolean algebra. It consists of columns for one or more inputs values, says P and Q. Means we assign some proportional to as a P and some statements as a Q. P and Q are statements whose have only result as a true or false. Now the output which we get here is the result of the unary or binary operation performed on the given input values. Some examples of binary operations are AND, OR, NOR, XOR, XNOR, etc. We will learn all the operations here with their respective tables, truth tables. Truth table for unary operations. Unary consists of a single input which is either true or false. Unary operations only give answers as true or false only. For these inputs, there are 4 unary operations which we are going to perform here. They are first logically true, only true values are here with this, logically false, only false values are accepted, logically identity and logical negations, means only negative values for these. Now start with first logical true. In this operation the output is always true, means if we take a sentence or take a statement whose results is always true, then it is called logically true statement or logically true proposition, right. Suppose P denotes the input values and Q denotes the output, then we can write the table as P when it is true gives true value, P when its value is false also gives the true values because it is logically true. Either it has false value but it gives answer only logically true answer. Next is logically false. Unlike the logically true, the output values for logically false is always false. It is also said to be unarily false. Table, let's come to the table. If we take P, P is our statement proposition whose first option we are taking true gives result false, and taking a value true false also give the result false because it is a logically false statement. Is it clear? Now logical identity. Logical identity means if we give a statement result true, then it will results true. If the statement has false answer, then it will give answer, logical answer false. Again, in this operation the output value remains the same or equal to the input values, means if we give true then result is true, false then false. So here you can see that we have some operations performs here whose only single proportion we are using, single statement results we are using. Now, next is logical negation. Logical negation gives always a opposite result. Means if we take a statement P whose first result is true, then its negation gives result false. If its result is false, then its negation gives always its opposite result, which is true. This wavy symbol denotes the negation of the value. Now, other than these four unary operation in logical or Boolean algebra, as I told you, connectives are used to connect two or more statements and form a expression of these and concludes and results as a single result, true or false, right. So, we have these 5 connectives. First is OR, symbol is down arrow and up arrow, negation, wave or not, implication means if then, arrow symbol, if and only if, double sided arrow. Now, start with OR connective. The OR operation of two proportions P and Q, written as P and symbol of down arrow Q, is true if at least any one of the proposition variable P or Q is true. It means it gives true value only when one of the statement is true, otherwise it gives false value. Its truth table is here. As we have two statements P and Q, so we have total 4 options, 4 combinations of their results. If P is true, Q is true, then it gives true result. If P is true, Q is false, it gives true result. P is false, Q is true, then it gives true result. If both are false, then it also gave false result. Or it means or means either one of them, one of these two statements have true result, then OR result will give true result. If both are false, then it gives false result. AND operation of two prepositions P and Q gives true result when both are same. Either they both have results true or either they both have result false, then AND result gives true results, otherwise it gives false result, right. So, only if we see here, we have only 2 true results, right. P is true, Q is true, then it is true, otherwise all have one false or 2 false, so it gives false results. Third is implication. Implication, we also know it as if then. If means first statement gives the result true, then second statement gives result true, then if then gives result true. If first gives result true, second gives result false, then concluded result is also false. First gives false, second gives true, then concluded result is true, but if both are false, then implies result gives false result. Alright. Next is if and only if. We can also say this is double sided implication, means P implies Q and Q implies P, means P implies Q statement and Q implies P statement combines gives P if and only if statement, right. So, as I written here, P implies P if and only if Q is a biconditional logical connective which is which true when P and Q both are same. Either they both are true or either they both are false. Alright. So, its truth table is here with you. Both are true, true. One of them is false, false. Both are false. Then gives the result true. Next is a tautology. Tautology is a formula which is always gives result true. If we have combination of propositions which connected by some connectives and result will be always true. That means its table, truth table is give result final true. Then this combination is known as tautology. I take a example here. Let P implies Q and P implies Q is a tautology. We have to prove it. So, for this I take P and Q two statements. As we know, we have 4 combinations of their results, which is here. Again, first statement is P implies Q, then I calculate P implies Q in third column, which is both true is true, one final true is true, both false is also true, right. So, its truth table is here. Then after getting this result, I have to combine it with AND P. AND P result is both true is true. If one of them is false, then false. So, this result is here. Then again this final result is implies to Q. So, if this table implies to Q, then true implies true is true, false implies false is also true, false implies true is also true, false implies false is also true. So, final table is always true, total results are true. So, this statement is a tautology. Next, contradiction. What is contradiction? A contradiction is a formula which is always false, means whose final result is false, right, for every value of its proportional variables. For explaining this, I took an example here and again making its truth table P, Q, P or Q, negation P, negation Q, then combining these single propositions by connecting them AND or AND result gives false, false, false and true, and then final combination of result gives false. So, its final table is false. So, this combination of proposition is contradiction. So, here with this, thank you for watching.